You have one VM. Traffic spikes. Oracle Cloud automatically clones it. Same config, same image, load balance, as many copies as you need. This is Oracle Cloud Instance Pools. To test the deployed solution, navigate to the load balancer URL. Each instance serves its own metadata page. Hit refresh, and the load balancer routes you to a different instance. Private IP, instance ID, availability domain, all pulled live from the Oracle Cloud Metadata Service. Let's take a look at the architecture before we build. Everything runs inside an Oracle Cloud region, US Ashburn in our case. Inside the region, we create a virtual cloud network with two subnets, a public subnet for the load balancer, and a private subnet for the instances. The load balancer sits in the public subnet. It's the only entry point. All inbound traffic flows through here. It distributes requests across all healthy instances in round robin and handles health checks automatically. The instances run Apache and serve their own metadata. Private IP, availability domain, and shape. Each instance reports its own. Instances are spread across fault and availability domains. This ensures the highest availability. Finally, two control plane objects tie it all together. The instance configuration is the blueprint, shape, image, startup script. The instance pool uses that blueprint to maintain the fleet, register instances with the load balancer, and replace any that fail. Go to the GitHub link in the description. Clone the repository and run check env to verify all prerequisites. If you need help setting up Oracle Cloud and Terraform, check out our Oracle Cloud setup video. Once that's done, run the apply script to provision everything in a single Terraform phase. The build is completed, so let's go into the console and see what got deployed. The instance pool shows 3 members running across AD1 and AD2. Each instance runs on the Ampere A1 Flex shape, Oracle Cloud's most cost-effective compute. All 3 backends are registered with the load balancer and health checks are passing. Autoscaling has been enabled. It will scale the pool up to 6 instances when CPU exceeds 60%. To test the deployment, navigate to the URL and the validate output. Each instance serves a page showing its own metadata, private IP, instance ID, availability domain, and shape. Hit refresh and you get a different instance. The load balancer is distributing traffic across the pool. Before we wrap up, let's talk about something OCI makes explicit that other clouds hide from you: fault domains. I like to think of availability domains as data centers, physically separate facilities within a region. Fault domains are isolated racks within those data centers, hardware that shares no single point of failure. In our instance pool, members are spread across availability domains and fault domains automatically. Hardware failure in one won't touch the others. AWS supports rack-level placement control using placement groups. GCP supports rack-level placement control with placement policies. Azure supports rack-level placement control with proximity placement groups. This functionality is less visible in the other cloud providers. OCI puts fault domains front and center, visible in the console, configurable in Terraform, and explicitly targeted by your instance pool. When you're done, run the destroy script to tear everything down: the instance pool, load balancer, autoscaling configuration, and all networking. GitHub and README links are in the description. If you found this useful, like and subscribe. If your team builds infrastructure like this and needs another engineer, my links are in the description.